The simulation I've chosen to explore demonstrates the principles of Ohm's law. Ohm's law describes the relationship between the forces at play within an electrical current, which are voltage, current, and resistance. Voltage is essentially the force that causes an electrical charge through a conductor. The current is the rate at which a charge flows through the circuit. Resistance is a measure of how much a particular material inhibits the flow of the electrical current. Because the voltage essentially drives the current and the resistance inhibits it, there's no way to independently increase or decrease the current while keeping voltage and resistance constant. The current depends on voltage and resistance. As the simulation demonstrates, if you increase the voltage while keeping resistance the same, the current will also increase proportionally to the increase in voltage. Likewise, if you were to decrease the voltage while keeping resistance the same, the current would similarly decrease. Similarly, the current is dependent on the amount of resistance in the circuit. If you were to increase the resistance while keeping voltage the same, you would see a decrease in the current, making it inversely proportional. If you were to decrease the resistance while keeping voltage the same, you would see an increase in the current. So with this information, for the largest possible current, you would have the most voltage and the least resistance. And again, by that principle, if you wanted the smallest possible current, you would decrease the voltage as much as possible and increase the resistance as much as possible. And with that, I'll conclude my breakdown of how this simulation demonstrates Ohm's law. I picked this simulation because of its relevance to our current unit, and I definitely feel I've gained a deeper understanding of this concept. I hope you learned something too. Thank you.